A limiting reactant problem. Sodium bicarbonate reacts with citric acid. We start with writing the formulas for the two reactants. And in this particular problem, the sodium bicarbonate is given as 1.7 grams, and the citric acid is given in the amount of 1.0 grams. Then we predict the products, and that would be the formation of sodium citrate, NaC6H5, and carbon dioxide and water. Making this a balanced equation, we have coefficients of 3 with the sodium bicarbonate, 1 with the citric acid, 3 with water, 3 with carbon dioxide, and 1 with the sodium citrate. Our next step would be to find which of these two given amounts acts as the limiting reactant. Will we use up all 1.7 grams of sodium bicarbonate, or will we use up the 1.0 grams of citric acid? I need to pick one. It doesn't matter which one I pick one of them and start my problem there. Since the sodium bicarbonate came first, I just picked it first, but it's in grams. My first step is to use the molar mass to change grams into moles. The molar mass of baking soda is 84 grams, is the equivalent of 1 mole. So I multiply times a ratio that allows me to convert from grams to moles of baking soda. Next, I come to the heart of a stoichiometry problem, and that is using the mole ratio from the balanced equation to determine how many moles of citric acid I would need for every mole of baking soda that I use. This comes from the balanced equation, and it was a ratio of 3 to 1, so that's where I have the numbers. And notice that I have two different materials, but the unit for this each is both moles. My final step, well, I could stop right there and know how many moles of citric acid I had, but since my given for citric acid was in grams, I'm just going to use one more step and convert moles of citric acid back into grams of citric acid. Its molar mass is 192, and so that allows me to calculate how many grams of citric acid are available and are needed. I need 1.3 grams of citric acid. I don't have it. I only have one. The need is greater than the availability, so that means that my citric acid will limit how much product can be formed. I will not use up all of the baking soda. So from this point on in the problem, I will always need to start with my known 1.0 grams of citric acid, because 1.3 grams just does not exist here. The next step. What is the theoretical yield of the water product? So again, I'm going to start with my limiting reactant, 1.0 grams of citric acid. Changing grams to moles using the molar mass from the periodic table will allow me to get moles of citric acid. That allows me to use the heart of any stoichiometry problem, which is the mole ratio from the balanced equation, to change my reactant into the product I want. This product happens to be the water, and I wanted to know the mass in grams, so I'm going to change moles into grams by using the molar mass of water is 18 grams per mole, and this told me that I have 0.28 grams of water forming. This is my theoretical yield. This is the expected yield based on the stoichiometry and the limiting reactant I started with. Now, actually, 0.261 grams of water formed. Experimentally, I only have 0.261 rather than 0.28. So, what is my percent yield? My experimental yield, which is what I really got in a lab setting or would be told to you in a calculation problem, in a ratio with the theoretical yield that I got from doing the stoichiometry problem, times 100 will give me percent yield. So that would be the 0.261 grams divided by the 0.280, I just threw in an extra sig fig there, times 100 tells me that this is a 77.1% yield of the expected product.